scale, we'll all know about the Kardashev scale, a tiered system used to measure hypothetically advanced societies based on their ability to harvest more and more energy. Kardashev Type 1 has all the energy from Earth. Type 2 has all the energy from the Sun. For 3, it's the galaxy, and so on. But there are other arguably better strategies for measuring predicted societal advancement too. And one such strategy was proposed as part of a multi-authored study published in the Astronomy and Astrophysics journal in July 2020. Written by the scientists Valentin Ivanov, Juan Carlos Beamin, Claudio Caceres, and Dante Miniti, and headed A Qualitative Classification of Extraterrestrial Civilizations. This study proposes a subtle but exciting rethink of the Kardashev scale. It argues that while Kardashev's technique does still serve an important purpose, if we just slightly change our perspective, then we can think about alien societies and our own future civilization in a whole new way. And perhaps finally we'll shed some light on the fabled Fermi paradox. The study argues that there should be a system which ranks, quote, the abilities of extraterrestrial civilizations to modify their environment and to integrate with it. Those two words, modify and integrate, are what chiefly sets this approach apart from the traditional Kardashev way of thinking. Rather than measuring advancement based only on the unlocking of more and more available energy, a la Kardashev, we're now asking how efficiently and effectively does a civilization use the energy that it has? There are 4 main levels to this particular model. Class 0 simply uses whatever environment it's already in. It could do this efficiently or inefficiently. It doesn't matter. Generally speaking, this relates to most simple animals without tools. Class 1 then advances by changing its environment in some way to improve its experience. Maybe it invents the wheel, goes through a tech boom, or travels to another planet. We can roughly understand present-day humans to be a high-class 0 society that's busy becoming a high-class 1. But then with the next level, we start to shake things up a bit, because Class 2 changes itself to improve its standing in relationship with its environment. And finally, Class 3, the highest level, is completely at one with the world around it. It helps the environment helps it, and everything exists in harmony. So what would life be like if humankind actually developed in this way? If it made the jump from an aspiring Class 1 to a self-improving Class 2? Well, here already is one way in which this new model differs from the Kardashev standard. Because it's not as though you even have to complete Class 1 before you can begin ascending to Class 2. The key shift in a Class 2 species can really be made at any time. It's simply the understanding that it's better to improve and upgrade yourself to suit your environment, rather than the other way around. For example, it's better to somehow alter humans so that they can survive on Mars at all times, rather than to alter Mars by building human-friendly habitats. And we can see the Kardashev-style question of how much energy you have at your disposal doesn't really come into it. To continue looking at it just in relation to our plans for Mars, it's clear that we will need a certain, probably high level of energy to ever travel to and from the red planet. But then, according to most current proposals, we'd need even more energy to build biomes, and then even more to terraform whole landscapes, or to build checkpoints out in space between here and there and Venus and the asteroid belt and everywhere else. But according to this new model, all of that can be avoided. All of that can be bypassed if we instead just change humans so that we're better suited to whatever the solar system can throw at us. The first, more traditional method requires us to generate more and more power, potentially pushing us toward Kardashev Type 2 style Dyson spheres. But with the second method, megastructures like a Dyson sphere might not even be necessary. Again, it all has to do with what the authors of the 2020 paper call the quality of energy use. A Class 2 society has modified itself so that it doesn't need to just endlessly harvest more and more energy. Instead, it can potentially use less to achieve the same or better levels of advancement. For a closer-to-home analogy, we can think about, well, the home. On the Kardashev scale, as soon as a Type 2 civilization has electricity, it turns on every light in every room and leaves it on indefinitely. All the better to see the surrounding area, which it's hoping to expand into. But with this alternative model, a Class 2 society only has the lights on if or when they're needed. To the point where, if you were on the outside looking in, you might not know that anyone was home at all. And herein lies another important distinction between the traditional and the contemporary models. The traditional Kardashev scale implies that we should be able to detect civilizations more advanced than our own, because they should be sending out all sorts of noticeable technosignatures. If an alien species were advanced enough to reach Type 2 and build a Dyson sphere around its star, for example, then we, even at our level, should be able to detect the Dyson sphere as proof that we're not alone. But to date, we've discovered no such thing. The new model, though, allows for advanced civilizations to have what the paper's authors refer to as low detectability. The idea is that it figures an advanced enough civilization would also be intelligent enough not to brazenly reveal its location to the rest of the universe. So a Class 2 would have all or many of the same capabilities that a Kardashev Type 2 enjoys, but without the techno-signatures that would blow its cover. Its energy use is efficient and therefore untraceable. Again, because it has adapted itself to its environment instead of its environment to itself. For the 2020 paper's authors, this fresh perspective could offer one explanation for the Fermi paradox, because it potentially allows for countless more advanced extraterrestrial civilizations to exist. It's just that they've all adapted to their surroundings and are therefore impossible for us to see. So is this newfangled Class 2 something which humanity can aim for? Well, in many ways, we're already on the road to becoming it. In science and modern medicine, we're always developing new ways to stave off illness, injury, and even death. We're recognizing the obstacles that life as a human on Earth places before us, and we're attempting to solve them. Be that via pacemakers to counter heart problems, or via CRISPR-Cas9 gene therapy to target genetic disorders. But still, there are some environments just here on Earth that humans struggle to survive in. So we're clearly a long way away from developing the biotech needed for us all to individually and reliably survive anywhere else in the universe. In many ways, both models complement and need each other. But equally, so much of our search for extraterrestrial intelligence up until this point has been guided by the Kardashev scale, and we have nothing to show for it. Not a single sniff of a stellar or galactic force anywhere. But this fresh system of classification allows for advanced civilizations that aren't just hungry for energy. For alien societies that don't just ruthlessly expand out and out and out until they control everything. On the one hand, it's comforting. On the other, it means that advanced intelligent alien species could be common, but just invisible to us. That they're there, but we just don't know about them. According to the 2020 paper, this alternative model to the Kardashev scale could also prompt us to rethink Arthur C. Clarke's famous third law. Instead of sufficiently advanced technology being indistinguishable from magic, it's now indistinguishable from nature. And that's what humanity would be on its way to becoming if it was a Class 2 society.